Alright, so let's go ahead and figure out these little quick answers. So a bug collides with the windshield of a car traveling down the highway, which experiences a greater change in momentum. Well, let's remember from Newton's third law, the force on the car due to the windshield is equal and opposite the force on the windshield due to the bug. Sorry, this is force on the bug from the windshield equals negative force on the windshield from the bug. Now, what this means is they're in contact with each other for the same time, and if we use the impulse formula, that can only mean that these two impulses are equal. So that means that J on the bug from the windshield is equal and opposite to J on the windshield from the bug. So if we're just looking at size of the change, since impulse is change in momentum, these two things have to be equal. Now we have, for part B, P equals mv. We're going to double the velocity, so now the new momentum is going to be P equals m times 2v. So we're going to double the momentum. That's it. Then 30,000 Newton net force exerted horizontally for 4 seconds in a 96,000 kilogram airplane. What is the impulse in the plane? J equals Ft. So that is going to be 120,000 Newton seconds. Now, D will skip. And E, unfortunately, is something that we have actually done already. So now we move on to problem F. So here a 0.40 kilogram soccer ball is traveling towards the goal and is batted back at the same speed. What is the impulse? It's really tempting to say that the impulse, the change in momentum, is 0 since these are the same, but be careful. It's mv final minus mv initial, and that's going to be 0.4 times negative 12 since it's batted back the opposite way, minus 0.4 times 12. So when we're actually done, this is going to actually end up being negative 0.96 Newton seconds. Actually, got the little decimal wrong. It's going to end up being negative 9.6 Newton seconds. If you want to do absolute value on the exam, I'm totally fine with that, but it should be 9.6 or negative 9.6 Newton seconds.